Hello and welcome back to Mrs. Riley's Maths videos. I'm working through Leaving Cert questions on the fundamental principle of counting. These questions come from Active Maths 3, page 303-304, which is exercise 11.2, questions 12 and 15. But you can just follow them anyway here on the video because I've written out the questions for us to look at. Okay, so fundamental principle of counting, just to get back to that. If one experiment has W outcomes and another experiment has T outcomes, the possible total number of outcomes is W multiplied by T. Okay, so that's what we've been saying so far. In this example, it's a bit weird because unlike a menu or choosing an outfit, you're choosing from the same pool of things each time. So it's not like you've got shoes, trousers and tops and you're choosing one from shoes, one from trousers, one from tops. Everything in this question here is a letter. So you're choosing from the same letters each time, but we'll talk about that now in a sec. An ID badge is made up of 4 capital letters. How many different ID badges are possible if no letter can be used more than once? And the example they give you is BRSV. So a key thing when you're answering these questions, especially at Leaving Cert level, is to have a method that works every time. And one method that works is to have spaces to fill in like this, 1, 2, 3, 4. Another one is to have them like this, actual spaces that you fill in 1, 2, 3, 4. So you can choose either method. I'll show you how I would use both methods. And what we do is under here we write the number of options that we can choose from. And up on here we draw an example of the option chosen. Okay, so the top line is example of the option chosen and underneath is the number of the option. So 4 capital letters, so we have 4 spaces to fill. 4 capital letters, I'm presuming the English language, they didn't say that, but I'm presuming that. So basically you're talking about A all the way through to Z, which is 26 letters. Okay, so we've got 26 letters to choose from. We've got to choose 4 of them, but you can't choose a letter more than once. So you can't have A, or T, 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 T. It has to be a different letter each time. So here we have 4 spaces. There's 26 letters to choose from for the first one. The first space could be any of the 26 letters. So 26 is what goes underneath. That's the number of options. And say I choose I for that. Okay. Now, I've got to put another letter in the next space. I've already used the I. There were 26 letters, but one is gone. So now there's 25 left. Okay, so I'm going to put 25 letters under here. I could choose any of those possible 25 letters. Let's decide to call that T. Okay, so T is now gone, and I've now got 24 letters left. Okay, 24 letters could go in here, any of those 24 letters. Let's say we choose P. So P is now gone, and there's 23 letters left to choose for the last space. And let's say we choose V. Okay, so our fundamental principle of counting says I now multiply these numbers. 26 by 25 by 24 by 23. So I just do that on my calculator. 26 by 25 by 24 by 23. 358,800. So there's 358,800 types of badges, different badges that can be made from the letters of the alphabet if you take them 4 like that. That's a lot, isn't it? Okay, 300 over 3.5. So anyway, 350,000. Now, how would I have done it if I use this picture? I would have done 26 choices for the first space, that's an I. 25 choices for the second space, that's a T. 24 choices for the third space, and I used P as my example, and here I'm using V as my example, and there's 23. I get the same answer, it's just a different way of laying it out. I strongly recommend that you find a method that works for you, and one of those might be a good one to use. Okay. Second question we're looking at, a code is made up of 2 letters of the English alphabet, lowercase, followed by 3 digits. Okay, so let's imagine what that looks like. So 2 letters of the English alphabet. Here's my code. 2 letters followed by 3 digits. 1, 2, 3. So these are my letters and these are my digits. Okay, a digit is a number, like 1, 7, 3, whatever. It doesn't tell me whether or not I should include 0, so I'm going to assume that my digits include 0 up to 9. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9. There's 10 digits. Okay, 10 digits. And the 2 letters of the English alphabet. So for the alphabet, there's 26 letters. Now, it doesn't tell me, I don't know why it insists that it's lowercase, it doesn't matter, followed by 3 digits. Okay, so 2 letters and 3 digits. So it's kind of like 2 different parts of a question. This is almost like the starters and the main courses, something like that. They're part of the same problem, but they're drawing from different things. And these 2 spaces were drawing from letters, and these 3 spaces were drawing from digits. So we're going to take it slightly differently each time. Okay, the letters and the digits are going to be different. So I'm going to work down here, because it says find the total number of codes possible when no letter may be used more than once. So the first thing, these are called restrictions. Okay, these are called restrictions. They're saying we want you to do this, but you have to do this. Okay, we want you to make this number of words, but you have to bear this in mind. A bit like you're allowed to go to the zoo to see the animals, but please don't climb over the fence. Okay, we love that one actually in our family. What does it say? Something like, please do not sit on the fence. This is at the zoo. Please do not sit at the fence, as you may fall into the enclosure. The animals might eat you and get sick. That's one of our favorite signs in the zoo, in Dublin Zoo. But anyway, sorry, that's called a restriction. That sign is a restriction. You're not allowed to climb over the fence. A restriction means you can't do this. Okay, so in this case, no letter may be used more than once. So we've got our letters and we've got our digits. So let's just write that again above them. This is our letters and this is our digits. Now, fundamental principle of counting says I'm going to multiply. So I'm going to multiply all these numbers together, even though some are letters and some are digits. So no letter may be used more than once. So just like a minute ago, I'm choosing my first letter here. I've got 26 letters to choose from. Let's say I choose Z for zoo. So I had 26 letters and I used Z. I now have 25 letters to choose for the next space. Okay, so 25 letters. Now, the interesting thing here, let's just choose O. Oh, maybe not O because it'll look like a 0. ZW, okay? 26 by 25. It doesn't tell me any restrictions on my digits, so I can repeat my digits. So I could use any digit at all for each of these spaces. There's 10 choices for the first one. I can repeat it, so say I have a 7 there, I could still have 7 here. Okay, or I could have a different number, let's say 3. But it's still 10 numbers that I'm choosing from. So 26 by 25 by 10 by 10. And then I do that on my calculator. 26 by 25 by 10 by 10 by 10, which is 650,000 different outcomes. Okay, 650,000. Okay, that's the first one. Part 2, no digit may be used more than once. So again, here's my spaces, 1, 2, 3, those are my letters, those are my letters, 2 letters, my first digit, second digit, third digit. I'll put a wobble down there just so that I know. So these are my letters. Now it doesn't say anything about the letters, so I can use the letters twice. So I've got 26 for the first space and I've got another 26. I can still use the same 26 letters. So let's do something different this time. Let's do X and Y are the 2 letters I chose, but I could repeat. I could have XX. And then my digits, I can't, no digit may be used more than once. So I've got 10, a choice of 10 digit for the first space. Let's say 8 goes there. I've used 8, so I've only got 9 left. 9 digits for the second. I've used, let's say it's 7. I've used 7, so now I've got 8 left. And say I choose 3. Okay, so 26 by 26 by 10 by 9 by 8. Let's zoom out a bit here so you can see this. 26 by 26 by 10 by 9 by 8 equals 486,720. Okay, and then finally, no letter or digit may be used more than once. So again, 1, 2, 3, 4, 5. So it's kind of like almost like a combination of these two, but we'll do it again. So these are letters and these are digits. So I've got 26 letters to choose from. I can't repeat, so let's put a J this time. I've used J, so I've got 25 left, and we put a D there, JD Sports. Okay, 26 by 25 digits. I've got 10 possibles for the first one, so let's say we put a 1 in there. So I've got 9 for the second one. Let's put a 2 in there, and then I've got 8 for the third one. Let's put a 3 in there. So 26 by 25 by 10 by 9 by 8. 468,000 possibilities. Okay, I hope that helps. Again, just stressing, make a method. Find a method that works for you. I actually like these boxes. I think that works because it's obvious what is the thing that I'm putting in the answer and what is the number of options that I have that I'm putting underneath. Okay, thank you. Take care. Bye-bye.